All right. So what we will be doing today, we're going to be focusing on piecewise functions. It looks fancy. We've got graph the f of x equals open brackets x minus 2 if x is less than -1 and x plus 3 if x is greater than or equal to 1. I went ahead and drew my coordinate axis with the x-axis and the f of x. Now what we're going to do this is we're going to use the conditions. These are our restrictions on the domain. So let me write this for our notes. This right here are the parameters on the domain. It's our restrictions on the domain. See, it says if x is less than -1. So in other words, this graph right here is going to be from -1 and to the left of it. So I'm going to consider some values on the left-hand side of x equals -1. For example, x could be -2, in which case I would want to know what the f of -2 is. Or x could be -3, in which case I would want to know what the f of -3 is. And once I gather all those points, I can connect those points. So for example, the f of -2 is the same thing as -2 minus 2. Well, that's equal to -4. I'll pause there for questions. So what we have here is we have the points x -2, f of x -4, which I can plot on my graph. That's the points -2, -1, 2, 3, 4. I follow the same process. Substitute for x being -3 minus 2, and -3 minus 2 gives me -5. Again, that gives me the points when x is -3. The f of -3 is -5. Now I'm going to plot that point, -3, then 1, 2, 3, 4, 5. I follow the same process again. I substitute for x being -4. So the f of -4 is -6. And now I have the points -4, comma, -6. What values could I have chosen? I could have even chosen fractions. You could have chosen any value for x, just as long as your x values are less than -1, not including -1. So, and I say that because here, as I do this graph right here, okay. So now I will graph the first piece of the piecewise function, by connecting the points. But because x is not equal to -1, I'm going to put an open dot right there. And I could keep going on with our x values on into -infinity. That was the first part of our graph. Now we need to look at our next part of our graph. Our next part of the graph says that f of x equals x plus 3 if x is greater than or equal to -1. So just as before, I am going to pick values greater than or equal to -1. So because it's or equal to -1, I'm also going to pick x equal -1, 0, 1, 2. I can keep picking points greater than -1. You could pick fractions. You could pick decimals. Okay. So now I will substitute -1 plus 3. -1 plus 3 is 2. So this gives me the point x is -1 when y is 2. So here, -1, comma 2, -1, comma 2, 1, 2. This time it's going to be a closed dot because x does equal -1. I will substitute again. 0 plus 3 is 3. When x is equal to 0, the f of x, or y, is equal to 3. So when x is 0, y is equal to 3 is right there. I keep repeating the process. Now, some of you are wondering, sir, is there a faster way? Yes, there is. When x is 1, y is 4. When x is 2, y is 5. I connect my dots. And we're done with our graph. Now, to look at our domain, the domain are the possible x values. Well, the domain goes from -infinity, and it goes all the way to -1, and it does not intersect, but it does continue on. See, this is not equal to -1 right there. And it's going to be the union, and then it goes from 1, including the number 1, all the way to positive infinity. Now on the range, there's a little bit more of a spread. See, we start from the bottom to the top. Our range are all the possible y values. And we start off on -infinity. And we go up to the value of y equals -4. Not including -4. See, because we've got that open dot, it's exclusive, so we use that parentheses. Union, because they don't intersect. And then here, we have starting from y equal to 2, but it includes the 2, and it goes up, y value keeps going up into positive infinity. Let's go ahead and pause there for a few seconds. So we went from having an equation of piecewise functions, and we went from that to getting the graph. This time around, we're going to go from the graph and go to creating the equation. So here's an example, and feel free to take a screenshot of that. That way you can copy it slowly at a later time. Now it says, write the piecewise function. So here we have our graph. So the first thing we're going to do is we're going to take notice of our domain. And we're going to look at how it's piecewise function. We're going to look at how it's pieced. So here I'm going to draw myself a little line right here. See how this graph is continuous, and then all of a sudden it's broken. So right here it becomes discontinuous. So here we have an x value of 1. And all these values from there to there, x will be equal to, or it will be less than or equal to positive 1. Then we have another break right here, because this line goes from there to there, so we have another break in our domain. And here we have the x values going from 1 to 2. And x is less than or equal to 1 is less than or equal to x. And also x is less than or equal to 2. And then from this point on to the right hand side, x is greater than or equal to, not equal to, x is just greater than, x is greater than 2. Okay. That was our first step. Notice the domain, and let's say domain parameters, right? Notice the domain parameters. In other words, what are the restrictions on the domain? How is it broken up into parts? It's broken up into 1, 2, 3 parts. So now what we're going to do is I'm going to start the same format as above. I'm going to say that the f of x equals we're going to follow the format. We're going to say f of x equals, and now I'm going to have 3 rows. 1, 2, 3 rows. And here I'm going to say if, and then the inequality. So we're going to have one equation if x is less than, oh, this is not or equal. is less than 1. Correction on this right here. This is not or equal because I have an open dot. I apologize for that. So x is less than 1. Here we're going to say if x is less than or equal, 1 is less than or equal to x is less than or equal to 2. And I'm using the or equal because it's a closed dot right there. And then we have our third restriction, which is f if x is greater than 2. So what I'm going to do here is I'm going to start off with the easiest one. This one right here is the easiest one. It's the easiest one because this is a horizontal line. And horizontal lines, if you studied your parent functions, the horizontal line is going to be f of x equals to some constant. And what is our constant? Our constant is 1, 2, 3. So the f of x is 3. For the next one, the next easiest one is probably the one on top. Why? Because I have a y-intercept. That's my b. I have a slope. I have a rate of change, which is 2 up and 1 to the right. That's my slope is 2 over 1, or just 2. So I'm going to use those two ideas and I'm going to combine them to get y equals 2x plus 1, 2, 3. That's my m and that's my b. So I'm going to say the f of x equals 2x plus 3. Now, probably the more challenging one is this one right here. So I'm going to show you a trick second. If you have 2 points, you can first find the slope. And then second, use your formula y minus y sub 1 equals m times x minus x sub 1. But I'm not going to do all that. Let me zoom in. I'm not going to do all that. What I will do instead is I'm going to imagine that there's an imaginary line that continues. And if it were to continue, my b for this one, my b would be equal to 2. And my slope would be a negative slope, negative 1 over 1, which is negative 1. But if you don't see that, don't panic. Just use these first 2 steps. That's what we did last week. So in this case, we're going to take this data and say that y equals negative 1x plus 2. In other words, f of x equals negative 1x plus 2. So on step 2, there was an embedded step, and that was to, let's call it 2a, use y minus y sub 1 equals m times x minus x sub 1. You might also have to use m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, just like you would have to have used here, or you could have used there, or you could have used your parent functions. You could have also used, like we did on this one, y equals mx plus b. Questions on that?